This is Gail Kovac for Gresham Barlow School District. This is Summer School High School Credit Recovery for Geometry. We're on learning target number 4. I can identify and transform figures through dilation. So we've already looked at a few transformations. That's changing the position or orientation of shapes without disfiguring them at all. And this last one we are looking at, dilation, is also a transformation. However, it's not one of the 3 rigid transformations. Translation is a slide, reflection is like a flip, and rotation is like a twist. This last one, dilation, is not rigid in the fact that it doesn't change the size and the shape of the figure. In fact, this one does. It's not going to change the shape or the way the figure looks. It's just going to change the size. So this is like photocopying something, but increasing the photocopy size to like 200% or 50%, making something bigger or smaller. So it's the same shape, but it's going to be either bigger or smaller this time. So on the left here, you see a dilation. It's kind of like how your pupils will dilate to brighter or darker lights. It's like still a circular shape, but it'll get smaller or bigger, right? So in this case, on the left here, we've got triangle STU, and it gets dilated to figure S prime, T prime, U prime, another triangle. Now notice that those 2 triangles there on the left, the black one and the blue one, the before and the after, they look like the same shape, but the blue one looks much bigger than the black one. It looks like it's just gotten larger. It's just blown up a little bit. So what we want to do is describe the dilation. What happened to that black triangle to turn it into the blue triangle? When we're doing dilations here, kind of like rotations, we're going to consider our origin the center of dilation. So everything either gets sucked into or blown out from that point. Now, let's take a look at our first point here. Let's look at S. So from S to my origin, it looks like it's up 2 over 2. But that line got continued to S prime, now mapping it to S prime. And it looks like we've gone double the distance we originally did. From the origin to S, that's up 2 over 2, across 2 diagonals like this. And then we do that same distance again to go from S to S prime. So this distance here was 2 diagonally across. Now it's 4 diagonally across. So the point here, S, was at 2, 2. And my new point, S prime, is now at 4, 4. So what happened to those coordinates? We went twice the distance, and my coordinates, they doubled. So we've got a scale factor here of 2. That means that the blue triangle, all of the points have been taken a double distance away than they were originally. Here's U to U prime. So that was also that was 1 down and 2 across. Now we're going to do another 1 down and 2 across to get to U prime. That again is a times by 2. And it should, hopefully, unless something's a little crazy here, be the exact same thing for T to T prime. From the point of dilation, our origin, that's over 2 up 1, another over 2 up 1 to get to T prime. Again, all those coordinates, they're going to double as well. So the dilation that happened here was a scale factor, and I'll put SF for short, is 2. So that was multiplied by 2. It got twice as big. It is now 200% what it was originally. So there's dilation. Let's take a look now. We just described it. Now let's do one ourselves here on the right. It says dilate the figure by a scale factor of 1/2. So instead of my new shape now being twice as big, I want it to be half as big. So I'm going to be dilating this smaller now instead. So here is my point of dilation. I want everything to either kind of blow out from or drop down into this point. And we'll start over here with point W. I'm going to connect here from W to my point of dilation, the origin. And instead of now me going out double, I can even do it a third time to go triple for a scale factor of 3 or 4 or 10 or whatever it is. I'm actually going to go inside now and go half as far. So I'm taking this distance from W to the origin and I'm cutting it in half. So now instead of going down one whole, I'm going to go down a half. And instead of going over 2, I'm going to go over just 1. And this right here on that point, on that line, that connection line, that's where W prime is going to end up. It is half the distance from W. Let's do the same thing for point V over here. I'm going to connect my point of origin to V in a very crooked line. And I want to go now half as far. So I want to go in the middle of this. You might be kind of like able to eyeball this and go, oh, I think it's going to end up right here. You're probably right, but I want to double check. To get from my point of origin to V, I needed to go down 1 over 3. I'm going to cut that in half. So now I'm going to go down a half and over 1.5 instead. So there is my point V prime right there. You can also check as well the coordinates if you would like to. My original V point was at 1, 3. Sorry, that is, oh my goodness, I'm getting mixed up. It is 3, -1. There we go. 3, -1. And now my V prime should end up half that. So I'm going to divide all of this here by 2 or cut it in half. So V prime should end up at, instead of 3, half of 3 is 1.5. And instead of -1, half of -1 is -0.5. You can double check to make sure that's where V actually landed, 1.5 and a half down. So that's correct. All right, we're going to go on to point C right over here. I'm going to connect here, and I think this is an easy halfway point to see right here. Haha, to C right here, sorry. All right, there's C prime. And yes, that is half the distance across C. If you found those coordinates of C to be 2, -2, you cut them in half for a scale factor of 1/2 to find C prime. That's a 1, -1. And let's do our last point over here. I've got P. Let's connect to my point of dilation. That wasn't too bad. So P is the points 2, 3. I'm going to cut those in half. Instead of 2, 3, I'm going to do 1, 1.5. And that's where my P prime is going to end up. All right, I am going to connect those 4 prime points together to make sure that this looks correct. I'm looking for some parallel lines here, and I'm already starting to see it with PW and P prime, W prime, and with W prime V, and then from C prime to V prime and P prime to C prime. So it looks like this got shrunk right into the middle here. It looks like it's starting to look like a spider web almost, right? And this new shape here, all of the lengths are going to be 1/2 of the lengths that they originally were. This shape is 1/2 of what it was before.